Welcome to the webinar today. The topic is large assembly modelling, and it's part 4 in a series that we've been covering on large assembly modelling. Today we're going to be looking at tools and tips for large assembly modelling. Just a little bit about myself, if you haven't been on one of my webinars previously. I'm a mechanical engineer with 25 years experience in CAD and at least 20 years experience in SolidWorks. I'm a certified SolidWorks expert and certified in data management for PDM as well. And that's just a little bit about me. If we move into the content now, as I said, this is the fourth part in the series. It was originally going to run on the 7th of September, but we had to reschedule. Unfortunately, it's been pushed out to this time of the year. So large assembly modelling, tools and tips for large assemblies. I'm just going to look at some further tools that can assist you to troubleshoot some of the common large assembly modelling issues, and also some tips to make working with large assemblies a little bit easier. And if we get some time, 2018's obviously been released. We might have a look at some of the highlights. Then there's some good ones in there, so stay tuned for that. The agenda for today, just wait till everyone can see that. So first up, we're going to have a look at some tools. The first of those is the performance evaluation tool. It's a quick tool just to help you narrow down some potential issues that you might see in SolidWorks. From there, we'll move into the assembly visualization tool. This is a little bit more powerful, and it's for interrogating SolidWorks in a little bit more depth. Then we'll have a look at the facility layout tool that's been introduced in SolidWorks 2017. So that's new for the release that came out last year. Then we'll have a look at SpeedPack, and then defeature and simplify tools. And then finally, we'll look at sub-assemblies as parts as a tool that you can use to help simplify your assemblies, large assemblies. And then we'll have a look at some tips, really just to round out the series. Okay, so let's jump into the content, and specifically performance evaluation. The performance evaluation tool can be found on the Evaluate tab of the Command Manager in SolidWorks, or you can go to Tools, Evaluate, and Performance Evaluation. In older versions, so SolidWorks 2015 and older, this tool was originally called Assembly Expert, and it was just on the System Tools or Tools Options toolbar. In 2016, they introduced the Evaluate category onto the toolbar, and it's been moved into that subcategory there with some other tools that we're going to have a look at. And so when we open this tool, there's a bit of a screenshot there of what that looks like on the presentation here. What it does is it gives you a summary of some of the information that's available about the assembly that's open. So things like are the components of the assembly in the previous version. It also details the number of resolved components in the assembly. Is large assembly mode active? It will indicate that as well. It gives us a mate report. So for the example I've shown there, it shows that 26 mates are evaluated when this assembly is rebuilt. It gives us some information about in-context referencing. So in that particular example, it shows an in-context circular reference. And then at the bottom of the screen, it gives us a general assembly breakdown. And one other thing that can also show up in this particular tool is the warning that components are far from the origin. In 2017, they optimized this, so we should see this less often in the 2017 release. But we still have the option there to analyze and fix that. A button will pop up in the performance evaluation dialog that we can click on, and it will bring those components closer to the origin and resolve that issue. Typically that exhibits in SolidWorks when you click on zoom to fit, and what will happen is that the whole assembly will disappear out of view because one of the components has been added too far away from the origin. So if I switch to SolidWorks now and just bring up an example file, that should come up on your screen shortly. Again, if we go to the Evaluate tab, and if I click on the Performance Evaluation tool, what you'll see in this particular assembly, and this was where the screen capture was taken from, 26 mates are evaluated. We've got some in-context circular references, but what I'd indicate here is that this is for information only. So please take note of the icons. If it's got a green check, it's basically just informational. Similarly, if it's got the eye in the white dot there, it's just there for information. If you see a warning next to it, then we might need to review some of that information. So in this particular case, I've got verification on rebuild switched on, and that could reduce our performance with that switched on in the assembly. So in that particular case, I'll just go into my system options, and I would go to performance and turn off my verification on rebuild and click OK. And then I can come back to performance evaluation, and you'll see that that's no longer shown in that particular dialog. Okay, so that's just one example. For in-context circular references, I can click on the show these parts, and it will give me a summary. Just wait for the screen to refresh there. It'll give me a summary of what's taking up the time, and if there is a specific component there. In this case, it might be this ASM boom 14-1, which is taking a little bit extra time due to some circular referencing. So we could go and check out what was actually happening there. So I'm going to click on return to the performance evaluation dialog, and I'm just going to close that off for now. And if I just come back to the slideshow, and we jump to the next slide. You'll see I've just made some details here about in-context relationships. So these are two of the most common issues that come up. And it's crucial to identify and resolve these for large assembly modeling. I've probably discussed a little bit on this in some of the other large assembly modeling webinars that I've delivered earlier this year. Basically, relationship conflicts, if they are present, what it's indicating is that there's not a one-to-one relationship between the configurations of the parts and assemblies. If they are present, you can usually click on a show these parts option, and there's a fix it button on that dialog as well, which allows you to create a derived configuration to resolve those issues. And again, I'd just reiterate that the icons that are present, if it's informational only, it's not a big concern. What's more worrying is if you get the warning, and particularly if you see the warning on the in-context circular references, you'll also usually see the traffic light icons displayed in the feature manager design tree, and that's usually a good indicator. You will see those first, and then you would go to the performance evaluation, and you can come down and show those parts to see what's causing your issue there. So it's important that you weigh up the recommendations of the performance evaluation against your design intent. If you're only seeing information only, then making changes might improve your assembly performance, but it might also compromise your design intent. Using external references is fine during development stages. I guess the proviso here is that when the design is nearing completion, that you should try and minimize the number of external relationships as much as possible to reduce those types of issues. Okay. So just to kind of summarize on the performance evaluation tool, that lower section where there's assembly statistics, it allows you to drill down into the assembly to see what's happening in terms of the numbers. The more mate items that you see here, so if we're talking how many top level mates do you have, the more mates that you have, obviously the longer the assembly is going to take to resolve. And I guess the advice here is that if you've got a significant number of top level mates, what you need to be doing is creating more sub-assemblies and pushing those mates into the sub-assemblies. The only missing information here is speed pack details, so we can't actually see any information on speed packs. That model that I just showed is mainly speed packs, but it doesn't reflect into this information here. So that's all well and good. What happens if we actually want to go deeper? What if the information in the performance evaluation is not giving us a deep enough picture? Well, that's when we reach for assembly visualization. The assembly visualization tool allows us to show the information of the assembly. It initially displays some default columns, and those default columns show the file name, the quantity of components, and the mass, usually by default. And there are some other parameters that we can show, such as graphics triangles, whether all of the components have been converted, the rebuild time, if there's any external references, if there's flexibility in the assembly, and we can also detail number of faces. There's also some other information we can show as well, but I haven't listed it all there. So what I'm going to do is go back to the assembly, and I'm going to launch the assembly visualization tool from the toolbar. This might take a moment to come up, and the reason it might take a moment to come up is because with large assemblies there's obviously a large amount of information, and so it's got to process all that information before it can show that in SolidWorks. So we'll just give it a little bit of time. Alright, so that's popped up now. And as I said, by default we show file name here, the quantity, and the mass. Now, what you need to understand in this particular example is, as I said, most of these instances are SpeedPAK. And so because of that, they're not actually detailing any mass information here. What I'm going to do is change this to graphics triangles. And you can see that for our ASM Boom 14, that this has 335 or 333,000 roughly graphics triangles displayed in this particular instance. Because the others are SpeedPAKs, they're not actually calculating the number of graphics triangles. I can also show other details in the assembly visualization. So if I click on the arrow to the right hand side of the column there, it gives me a menu, and I can click on more, and we can select something like open time, which is probably one of the most critical things with large assemblies. So if I click to select that and select OK, you'll now see that we're getting a little bit more detailed information. So the column's now displaying SOLIDWORKS open time, and this information here for the open time is displayed in seconds. So if I mouse over that, it will briefly show a tooltip indicating that that is actually 1.2 seconds. Excuse me. And the other thing to note here is that there are some coloured bars shown over the components. What those bars indicate is the graphically how much time they are taking. So we can actually turn that on or off with the show hide value bars option there. So if I just turn that off, it removes that. And if I toggle that back on, it just gives me a graphic indication of which component is taking the longest time to open. If I switch this to mass, it would calculate that bar shading based on mass. Okay, some of the other icons we've got in here, currently that's shown in a nested view. If I click on that button, it actually shows it in a flat view, so we can see each of the components individually. Currently, the third icon here is showing grouped or a grouped view, so any components where there's a number of them, you'll see the quantity here is 9, and the components are grouped together. If I click on this icon here, it will ungroup those and it will show them all individually. So I can actually drill right down into the assembly and see each individual component. I'm just going to regroup that and re-nest it. And what you'll also note on the left-hand side here is a slider. And if I drop my mouse over that, you'll see that I can click and drag those sliders around. So I can use that to minimize the amount of information that's actually in the shown in the assembly in coloring. And the coloring is also related to the currently sorted column, which is indicated by the arrow underneath. I can also just click in here to add a new slider, and if I click on a color, it will further optimize the way that that assembly is broken down. So at the moment, anything that's in blue, which is not very much at all in that particular assembly, perhaps that linkage there is shown in blue. That's taking the least amount of time to load into the assembly based on the open time. Okay, and you can basically add as many of these sliders as you want to drill down into the assembly and break it down into opening times. And similarly, if we change back to graphics triangles, obviously in that particular instance, it's going to show some different information. If I go into the dialog to select a different property, I can choose to show something like rebuild time. I can drill down and see what's taking the longest times to rebuild. And whilst that's just updating there, at the moment, the thing that's taking the longest time to rebuild is that boom component. And the reason being is because that component's not actually speed packed, so that's what I would expect. And the other thing it's indicating there is it's taking 40.1 seconds to rebuild that information. There are some other options in the side menu here. We can edit columns, we can add columns, we can change the precision that's related to whatever it happens to be that we're looking at. We can add a display state, and we can add we can save and load styles. What that refers to is the coloring that's in the slider bar on the left-hand side. The other option we've got here is to save as. So if we come in and start building up a number of columns, looking at a number of different items within that, open times, rebuild times, etc., we can actually save this information out into a table. And we can specify whether we want to look at the top level only, the parts only, or whether we want to have that indented so that we can see sub-assembly detail as well. And or we can also choose to exclude hidden components, and we can save that out to either Excel or to a text, a CSV, or a PDF document. So you can keep that information outside of SolidWorks for quick reference, and also for troubleshooting large assemblies. You could also provide that back to us if you are having major issues and required support. Rather than sending the files, we might be able to use that to quickly drill down and work out what's causing your issues there. But it's there for you to use as well. All right. So that's assembly visualization in a nutshell. If you want more information, you can click on the help button within assembly visualization tool, and there's some more detail in there about how to use some of those options. Looks like someone's asking a question. I'll just take a moment to see what that is. Open time, someone's asked why they can't see open time. It may well be that if you're not using SolidWorks 2017, that might not be possible. That was only added, I think, in 2016 or 2017. So if you're working on an older version of SolidWorks, it may not be visible. If you are on 2017, that might well be worth emailing me later on just to follow that up, because it should definitely be visible on 2016 and 2017. Okay. All right. I'll keep moving, and what we're going to have a look at next is the facility layout. So this was introduced in SolidWorks 2017. And basically there's 3 stages to getting this facility layout working, and those 3 stages are basically publishing an asset, and that process involves defining a ground plane within SolidWorks, and then using magnetic mates to attach components together. If we have a look at an example in SolidWorks, we'll just wait for the screen to refresh for everyone. So what I've got here is basically a layout with some conveyors in it, and those conveyors are made up of, if you have a look at the Feature Manager design tree, they are all speed-packed versions of those particular sub-assemblies. If I go to Insert and choose to insert a component, so I'm just going to choose, and I need to go into another folder just here briefly. Just going to choose a spur conveyor, so that should pop up on your screen there. And I'm just going to open that one up. And you'll notice as I drag that across the screen, or even once the screen refreshes there, you'll see that there's a number of pink dots shown on the screen there, including on my conveyor. And you'll see as I drag that conveyor close to any of the pink dots on the existing geometry that it highlights, and it will allow me to position those alongside any of those pink dots. So that's just going to add that, snap that onto the end of the conveyor there. That's not actually where I wanted it, but that's what we can do with the facility layout. So by defining a ground plane, it's automatically snapping that component into the ground plane there. Let's just go back to assembly and we'll browse again. But basically any of those locations, we can bring that assembly in. If I snap it onto that one, you'll see that it snaps that in alongside our assembly there, and it basically makes putting new components into an assembly a lot easier operation. I can also grab hold of an existing assembly, so if I just click on an edge there and start dragging, you'll see that I can then position some of these alongside each other, and those magnetic mates where the pink dots are allow me to just snap those assemblies together. And so in terms of putting an assembly together, it just simplifies that process. I've got a robot here. If I hold down my control key, I can drag a new instance and I can snap those dots together, and you'll see that it positions that robot on the other side of that cell as well. So we could have two robots there. I realize they're clashing in that example, but that's I'm not going to worry about that too much. Similarly with these figurines, if I drag that, you'll see that he snaps into that position there to position him alongside the conveyor. So what's driving all of this? If I open up one of these sub-assemblies, what you'll see here is we've got some published references. Just wait for the screen to refresh. Okay, so I've got a published asset here. And you'll see if I open that up, I can see that I've got a ground plane defined within that sub-assembly. I've also got some connectors predefined. So if I click on that, you'll see that that connector has got a vector arrow on it indicating where it's going to snap, so normal to that step-off face on the rollers there, and at the other end it'll be normal to the face there, and that's simply defined by your normal geometry. If I actually go into the speed pack definition here and edit the speed pack, just wait for that to come up there. You'll see that all of those references are listed in the reference section of the speed pack, as well as the ground plane as well. Okay, and we can edit those from there. If we wanted to publish a new asset, it's as simple as going into the insert, and there's an option there to publish assets from there, and it's just basically selecting references to correlate these ground planes and connectors that you might want to define. And then if we go back to the top level assembly, discard those changes. All right. You'll see that I've got magnetic mates on or off. They need to be on for me to be able to see those pink dot references to allow snapping automatically within the assembly. All right, just coming back to the PowerPoint. So let's talk a little bit more in depth about SpeedPAK. SpeedPAK's had a bit of a bumpy history in terms of use and stability. This has been improved in the last couple of releases. For 2017 specifically, some of the updates there are you can include reference geometry and curves in the SpeedPAK, and you can select sketches from any level of the assembly to include in a SpeedPAK. Previously, all the top level unabsorbed sketches were included in the SpeedPAK. You had to suppress top level sketches that you wanted to exclude, and you could not select sketches in sub assemblies. So in 2017, top level sketches are not automatically included, so that's a big bonus. Moving on to the next slide. What is SpeedPAK exactly? If you're not familiar with SpeedPAKs, basically the SolidWorks Parasolid information and SolidWorks features are converted into graphics information. It quickly unloads all the unnecessary heavy information from the assembly, including the component feature detail and the component Parasolid information. So in previous webinars, I discussed about Parasolid versus the actual tessellation that's carried with the model. With the SpeedPAK, it's only the tessellated data that you're actually seeing in most cases. It only keeps the information required to mate, so some specific solid information is retained where you need mated faces, and faces and or bodies required for the application of drawing dimensions. So you can specify faces or bodies that you require in the drawing that you need to reference from, and any reference geometry. And the concept is that you can still see what the assembly looks like in your graphics area on the screen, but you only need to retain the model information for that's critical to mating and keeping the assembly together. And so in the sense of using SpeedPAK, you're really speeding up what you're seeing or on the screen. It increases your performance, but you still get to see effectively the whole model. The advantages of using SpeedPAK: instant geometry conversion. You can remove all features if you just want to create a graphic SpeedPAK. You've got the ability to decide which faces and bodies you wish to retain as Parasolid. Faces defined in mates can be retained automatically. So in the assembly, if we just take a look at our bolter assembly again in SolidWorks, and if I just turn off the assembly visualization there, and perhaps if we open up our boom subassembly, we've got a number of subs in there, if I right click on one of those sub-assemblies, you'll see that I've got some speed pack options, and I can create a mated speed pack directly from that sub-assembly, and what that will do is it will retain only the faces required for mating, or I could create a graphic speed pack, in which case everything will be converted to graphics. So if I just do a quick mated speed pack here, you'll see that it goes away and does that. The representation in the Feature Manager design tree will show the speed pack configuration shown. And if I mouse over that, we can see what is actually retained. Now, in order to do so, by default, when you're creating speed packs, there's a thing called a feature called the speed pack circle. And if you use the Alt-S option on your keyboard, what you will see when that's turned on is only the geometry which is required for mating. So you can see those faces reasonably easy there. Anything else is graphics. And when I hover over it using the speed pack circle, graphics are not displayed. Okay. If we return to our main assembly and use the speed pack graphic circle, you can also see that the bulk of this model is speed packed, and only the faces which are used for mating are visible in the assembly. Okay, so that's the speed pack circle tool. Just come back to the PowerPoint, and what are some of the downsides or considerations with using SpeedPack? SpeedPack's not automatically updated when its parent's configuration is updated. A warning will be shown on the model, but we can perform a manual update. There's a update SpeedPack button that's on the assembly toolbar, and you just need to click on that and it will update all SpeedPacks within the assembly. And it's just a one click, so that's not too much of a downside, but you need to be aware that this is not an automatic process in SOLIDWORKS 2017. Only edges of the preserved faces can be dimensioned, so this is specific to edges, not faces. And the other consideration here is that drawings are automatically displayed in draft quality mode, and you cannot modify this if you're using SpeedPack. If you require high quality drawings, SpeedPack cannot be used for those specific views, and that usually becomes an issue if you've got to save out to either DXF or PDF, Adobe PDF file formats. When you're exporting to either DXF or PDF, you need to have high quality drawing views. Okay, and I've already mentioned about the graphic circle there. Some other tools that we can use in SOLIDWORKS to simplify. One is the D-feature tool. The key advantage of using this tool is that it maintains the parametric relationships between the original model and the simplified ones. If you do a file save as, those parametric relationships are not necessarily retained. For assemblies, you can specify components to remove from the model. For multi-body parts, you can specify bodies to remove from the model. The D-feature tool uses a wizard-based approach to assist in selecting details to be removed using a number of different techniques. So if I just switch back to SOLIDWORKS, and I'm just going to open up a different file here. So we might go for just our basic universal joint. as an example, and we need to go to the Tools menu and select the D-feature option. And you can see step one, we can start by removing any unneeded components. So you might just say, okay, we don't want to see the spider in there, and maybe the pin at the rear. And alternatively, we can select just internal components. So if you've got a fairly complex machine, you don't want to see any internal components, you can select an option there. You can also select small components based on % of the assembly size, and then you can have selected components. So if I click on that box, you can see I've selected the spider and pin there. You can also specify exceptions. So if you've used some of those automated options at the top and you still want to show them, then you can or deselect them in here so that they're retained. Step two, if you want to specify motion between components, you can specify that here by creating groups. You can have motion between groups, but not between components within groups. So if you've got components that need to have motion between them, you can specify that there. SOLIDWORKS fills parts with materials to remove internal details such as holes, etc. If you don't want those holes to be filled in, then you can specify features to keep there as well. And there are some auto tools here if you want to select those as well. And then obviously it goes through the process there. And then finally it says to remove in step 4, select items you want to remove that were not automatically selected. So if none of those other options selected information you wanted to remove, you can do it here. And then the last step is to actually click OK on the D feature. Now, there's some options here. You can just store your settings for future use. Those settings are saved in the model. You can save the model out to a separate file, and you can also select an option to link to the original. So you can create a completely separate file. You can also publish this model to 3D Content Central, and obviously this is really an option for people who are wanting to get their products up onto 3D Content Central so other SOLIDWORKS users can download them. And then it's just a matter of clicking OK to finish that particular D feature option. When that's completed, you'll see a D feature icon in the design tree. As such, you can see it here, and that's retained with the model. It creates a derived configuration. So if we just jump back into the PowerPoint and go to the next slide, it's a bit of a summary here. We can use this tool for multi-body parts and single body parts as well. I guess the focus here though is for assemblies and large assemblies. So these are the pages that we've just been through, and these are the tools that are applicable to those particular pages in the process. The other tool that we can use to simplify in SOLIDWORKS is called Simplify. This tool is really there to simplify configurations of a part for use in analysis, so finite element analysis, simulation. It basically allows you to suppress features below insignificant volume or by features, defined as a simplification factor, and it's used primarily for analysis preparation. The results in creating a derived configuration of the part or assembly, and the supported features here are chamfers, extrudes, fillets, and then depending on whether you select the simple and hole wizard options, holes, or if it's volume based, then it's revolves. And I guess the only other downside to this is that it's it doesn't support assembly features. So if you've got assembly cuts or extrudes through the assembly model, then they aren't actually supported in the Simplify tool. But it's another option if you need to reduce the amount of detail quickly in a SolidWorks large assembly. Okay, the final tool that I really wanted to talk about here was sub-assemblies as parts. And new for SolidWorks 2017, if we save a sub-assembly as a part, it preserves the drawing references. So anything like dimensions, notes and annotations, those references are maintained when you replace a sub-assembly with a multi-body part created from the sub-assembly. And the process is basically just right-clicking on the sub-assembly and doing a save as, and making sure that you click on preserve those geometry references, and then you've got the option to select whether you want to save just the exterior faces, exterior components, or all components, and then it saves it as a part, which then references back into the sub-assembly. And so this gives you a way of perhaps reducing the overhead in the assembly by replacing some sub-assemblies with a single component rather than having the sub-assembly structure with mates, etc. in there. Okay, moving on, just to look at some tips for large assembly modeling. In sub-assemblies, as I mentioned before, they raise the performance, especially in lightweight mode. So avoid flexible sub-assemblies and watch the number of maximum mates in the top level. A few releases ago, it used to be advised that you should aim to keep your number of mates below 150 at the top level of any assembly. SolidWorks have since advised me directly that there is no actual cap, but ideally you should still be using sub-assemblies to help minimize the number of mates at the top level. And I guess the what you need to realize is that the mates folder, all of the items that live in that are effectively solved as one big matrix. So if you're familiar with linear algebra and solving linear algebra equations, they're usually done in a matrix. The more mates you have in your mates folder, the more elements you're going to have in your matrix. And in order to solve all of those at one time, SolidWorks needs a lot more power. And by minimizing the number of mates by using sub-assemblies, you minimize that solve time. Transparency in assemblies. They influence the behavior in 3D and influence calculation time in 2D, so on your drawing sheets. You get better performance with SolidWorks in 3D using order independence transparency. Around about 2014, SolidWorks optimized for using order independent transparency. So if you've got a graphics card which is newer than about 2014, they should also be optimized to use OIT. It's a hardware function on the graphics card that SolidWorks will support if it's there. Basically, it was introduced to stop bleed through on drawings, etc., of lines that might have been in the background or edges coming through on the front face of a drawing view. So that's why it's supported, but it also helps to improve transparency performance as well. If you're using shaded view, just be aware that hidden lines also have to be calculated. So yeah, that can also affect performance for large assembly models in drawings. Patterns, if possible, use the geometry pattern option. I've got a screen capture of it there in the PowerPoint. why would we want to use that option? The geometry pattern basically uses the seed geometry for all instances in the pattern. Maybe some instances where this is not generated, there may be some instances where this is not the generated result. If you've got a pattern of a feature that has a end condition that needs to be observed by all the instances but varies along the pattern length, then you might need to not use the geometry pattern. But in most cases where the pattern is the same as the original instance, use the geometry pattern option, because it reduces the performance required. Alternatively, you could just pattern the faces only to create the desired feature. You could use sketches where possible instead of features, or the last option there is to use real view only patterns. So if you've got a specific hole pattern from real view, you can see on the right hand side of another screen capture there, you can use the cosmetic hole pattern to replace an actual physical hole pattern in the model. Obviously, you need to have real view active on your machine to be able to do that. And degrees of freedom, remove all degrees of freedom where possible. There are 6 degrees of freedom for any component in SOLIDWORKS. The fixed float options and mates are used to restrict or remove those degrees of freedom in the model. The 6 degrees of freedom are translation in the X, Y, and Z directions, and then the other 3 are the rotation about those axes. So for all SOLIDWORKS components which position is not completely defined, SOLIDWORKS has to calculate the position. So every time you're rebuilding, SOLIDWORKS has got to recalculate the position of components which are not completely defined, and that's why it's better to define completely, so you don't have a minus sign in front of the parts in the feature tree. And again, it's also the same for sketches. You should always make sure they're fully defined, particularly when a product's going out for production. Performance in terms of mates as well. The fastest mates to solve are relative mates, so coincident and parallel. Those are basic standard types of mates. Logical mates, width, hinge, gear, etc. So some of the advanced and mechanical mates take a little bit longer. Distance mates take longer again, and limit mates are probably the most intensive to solve in terms of performance. Limit mates can be useful, but they can also bog down your performance in large assembly models. So it might be better to replace that with something else if possible. And I guess my last tip there is to avoid mates to reference geometry, so patterns, assembly features, guaranteed to create longer calculation time and also result in context circular reference issues. And then we've got just a little bit of time here, so the bonus section, 2018, what's new? They've updated the asset publisher for the magnetic mates in 2018. Basically, if you want to attach with magnetic mates, you get a little icon that pops up when you're trying to attach now, so you can automatically lock that into place. The asset publisher now allows for multiple ground planes rather than just the one that we had in 2017, but you can only use one at a time, but obviously having more than one is of a bonus when you're setting up that facility layout. We can change the transparency of an assembly or a multi-body part at the top level. That can be quite useful in terms of performance again, because we can just set the transparency for the top level. Check entity enhancements. We can use the check entity tool to quickly find out if there are face errors and those sorts of things, particularly important for imported bodies in a large assembly model. So that's a real bonus. We've got a new type of mate, which is the perpendicular mate. Performance evaluation enhancements. So there's some additional enhancements to that tool in 2018. I'm not going to go into detail here. Smart explode lines. So for exploded assemblies, we can automate the process of including explode lines. There's been some speed pack updates, auto update options. So you remember that I mentioned that in 2017 we can't automatically update. There are some options for that now in 2018 under the system options and assemblies. And there are more, but I'm hopefully going to run a webinar next year more specifically on updating all of these details. So stay tuned for that one. That pretty much concludes the webinar. If there are any questions, I'll filter through them now. Looks like there might have been a few questions. I'll just see if I can answer those now. If you've got further questions, please let me know. Do you have to create separate speed packs for each configuration of sub-assemblies? You don't have to. I guess it depends on which sub-assemblies you're going to be using, but if you've got multiples that you're using, it might be of benefit to create those speed packs for each configuration. They are a derived configuration, so if you wanted each configuration to open in speed pack format, then you would probably likely have to do that, yes. This webinar will be available through the MyInterCAD tool if you wish to watch it again, as well as all of the previous webinars. Obviously, please feel free to contact me if you've got any questions with regards to anything that you've seen. My email address is on the last slide. I'll just slip back to that again. If you've got any questions, feel free to send an email to me, and I'll be happy to assist with any of those that you might have.